partial pressure. So somebody asked me to write that better. And so partial pressure, Dalton's law, which is not this one, okay? P total is equal to P1 plus P2 plus P3, dot, dot, dot. It just depends on how many different gases are present in the sample. That will tell you how many different partial pressures you'll have in the examples. That's a generic law for Dalton's law on your foldable. What was the second law we talked about yesterday? See, we did Graham's law, which was what? Okay, rate, and we did a comparative example with that, right? What was the entire formula? Okay. Okay, so here's our generic format where you have your inverse relationship between the rate of itself and its molar mass, the rate of itself and its molar mass. So in this question here, which of these laws is applicable? In this first question of paper 1. This second one, because one is asking for molar masses and saying it's fusing up to 4.5 times faster. You should be able to read a problem and determine the law in about 3 seconds based on the data given to you. So we have a rate of fusion of 4.5 times difference between krypton and an unknown elemental gas. Which one is moving faster? Unknown or krypton? Unknown. I know you don't know, but can you read and tell me why?
Because it says faster
than krypton, right? So it's saying the elemental gas is diffusing that many times faster than krypton, so that it means that itself is going to be the lighter one because it's moving faster. So set up the problem with unknown on top, rate of unknown, over rate of krypton. So that first sentence is just telling you who's lighter. Do you see that part? You understand that? That's just simply telling you who's lighter. It's saying the unknown element is lighter because it's moving faster. Well, it's moving 4.5 times faster, so that's what this rate is equal to, so I'll just write that over here. Okay? The last thing we need to do in this setup is to implement the molar masses, and it says rate is equal to the square root of their molar masses. Whose molar mass is going to go on top in this part over here? Right, what's krypton's molar mass? 83.8 grams per mole. And then what is unknown's gas, or what do you want to call that? X, because that means we will solve for X. Okay, so mathematically, how do you solve? This, if I want to pull X out of the denominator, I can't do it immediately. What's the first step? So square everything. So square this entire thing. So 4.5 squared is 20.25. And then this squared is what? 83.3 over X, right? Because you just basically remove the square root. So that's 83.8 grams divided by X. So then how do I isolate it? X. Okay, I hear flip-flop, I hear multiply by X. So basically what you're saying is that you're going to multiply by X on both sides, and then this X over here is canceled. So then you're going to take the 20.25 and you're going to divide the 80.3 by that. So you're going to do X is equal to 83.8 grams per mole divided by 20.25. And what do you get? 4.
Ms. Enlow?
Yes?
At 1:45, could I have Ryan Ferguson for his special?
Thank you.
Thanks.
Now, if this is our final mass, what is the gas? How do you figure that out? Periodic table. So you're looking in the gas area, which is in the upper right-hand corner. Who is this? Helium, because that's its molar mass. Helium's molar mass is 4.1-ish, 4 grams per mole. What if instead the molar mass had been 28 grams per mole? Look at the periodic table. 28 grams per mole. So that's the part I wanted you guys to think about, okay? You say 28 grams per mole is silicon, right? Everybody's looking there. It's silicon. Is silicon a gas? It's actually like a solid. This is a silicon wafer, wherever it is. This is a solid. So I want you to think about what gas could have 28 grams per mole that you know is a gas. Nitrogen, diatomic nitrogen, because that's how it exists in nature. As N2, which is 28 grams per mole. So don't only just look at the periodic table, use your logic behind it. Like, is this a gas? Can this be the question? Can this be the elemental gas that's in the question? And that would be healing for this case, but another something for another case. Okay, I'm doing 17 on the problem set. Now, whenever you're given something like this, let me copy and paste this on the list. You guys should first be able to tell me every given known to man here, and then from there, determine the actual formula that you'll be implementing. So here is the wheel of death. Hold on. Okay. Okay. So we have, first off, what is the reaction? Can you tell me what's reacting? So zinc and hydrochloric acid make what? So ZnCl2 for zinc chloride and H2 for diatomic hydrogen gas. And there's a balance here. So that was what kind of reaction? Zinc replacement displaces the hydrogen from acid to make hydrogen gas. We have 7.68 grams of zinc reacting. Is this able to be put into a gas log? No, why? First of all, it's grams, but second of all, it's not a gas. Do not put non-gases into gas logs. It is a solid metal. We'll convert to that later. We'll convert later on. What volume of hydrogen gas? It's nice to label the volume of what you're talking about, because then it will always remind you have to be finding the specifics of this in a second. At 20 degrees C, so temperature is what in Kelvin? 293 Kelvin, and 740 millimeters mercury. What did you have to do with that? Convert to atmosphere. So how do you do that? Divide by 760. So really what you're doing is multiplying by 1 atmosphere over 760 millimeters of mercury, and that gives you 0.973. I'm sorry, I just lost my train of thought. There you go. There's our pressure. There's our temperature. I don't have that complete formula set up for PV equals RT yet. What am I missing? Okay, so R we have in our head, right? We know R. And then N, how do I find N? Okay, so I heard two things. First off, our real question in this problem is what's the volume? We are solving using PV equals RT. We are going to use this, and we're going to solve for volume. But we need every other variable first. So what we're first seeking is our N value for hydrogen. We don't have that. So we are going to use our grams of zinc to get that first. So we're going to use our molar mass conversion, which is what? 1 mole of zinc is what? 65.39 grams of zinc. So zinc now has been converted from grams to moles. Who cares about zinc? Get me to something important like mole ratio. So going to hydrogen, and that's a 1-to-1. I know it's stupid because you're multiplying by 1, but it keeps you in the habit of always thinking about, am I in a gas? No, I have to get some moles of that gas. And that's going to, in a different case will be a different ratio. So that gives us 0.1175, right, moles of hydrogen. And I don't like to round here because I'm not done yet. I'm not to my final answer. So this is our N value that we will plug in here. So check, we do know our N value. So I need to now rearrange this formula to solve for what? V. So how do I do that? Divide by P on both sides. So V is equal to NRT over P. And I told you guys I need you to put your units in there, show the cancellation of them, show what you got to show in order to make sure that you yourself are comfortable with this. N value 0.1175 moles. I'm going to run out of space, so times 0.0821 atmospheres liters per mole K. And then temperature is 293 Kelvin. So this is all in the numerator, okay, over our p-value of 0.973 atmospheres. What units cancel? So literally cancel them out, okay? So the atmospheres on top and bottom, moles on top and bottom, sorry. So this is the numerator and this is the denominator of the numerator. And then Kelvin and the R constant and the K for the Kelvin and the temperature. So the only unit left is right there. It's on the very end of my board. It's liters. So that's, what is that? 2.9. Around, okay. 2.88 on this paper for some reason. Liters, so a little, a little less than 3 liters is our final volume. But it's more of the setup that I'm looking for, because I can always give you guys partial credit, because sometimes somebody will just mistake, put a wrong number in. So I'll give you full credit based off your work, if I can at least find your error. If your work's not legit, then it's not going to cancel units or anything. I won't give you full credit. Okay, so that's gas stoichiometry, where we have to implement both a reaction with a little stoichiometry, we have some molar mass conversions, mole conversions, and the ideal gas law together. How about number 9? I heard some issues with number 9. In the question 9, you actually needed to find. So a chemist collects a sample of hydrosulfuric acid over water at the temperature of 27. That statement right there, over water 27 degrees Celsius, is saying to you there's water vapor present inside of whatever they're collecting it in. So you have to find the water vapor pressure like we did yesterday in the lab. So you can just, they're everywhere. That is just something you can Google online. I should have put in the problem. I meant to tell you yesterday, but we were doing a couple other things. The water vapor pressure is 3.73 kPa. So P of water vapor is 3.73 kPa. And it tells us that the entire pressure of the gas is 207.33 kPa. So that's basically PT, which is our P total. All the other stuff is actually irrelevant because it's not changing. The water volume is not changing. The gas temperature is not changing, and the gas volume is not changing. So we have a P total and a P water. What are we looking for? The other value, right, for the P gas. That's our question. So basically what you'll do is set P total equal to P water vapor plus P gas. This is Dalton's law again. So PT is equal to P water vapor plus P gas. How do you solve for P gas? Just subtract. Yep, so PT subtract P water. So that's a Dalton's law example. Okay, do me a favor. Let's see where we are. Please start. Don't write on paper for me. Please start on number 10. Number 10. So please do not write on this. This is another gas image from. Start on number 10. In order to next to that. Start on number 10. Mama, what do you need? Over here. Raise your hands and need a calculator.
This is a double replacement.
Get out your own periodic table if you need one. You probably will. Guys, raise your hand if you're working on number 10. Okay. Do you guys see the reaction given to you? Yeah. So why you don't need to write your own. The reaction given to you.
I'm stupid. Really? I'm good at ammonium
Yeah. I was like, oh,
I'm so
just making
stupid.
sure.
I literally read ammonium sulfate. Like,
That's actually on the
yes. So I asked killing the keyboard.
No, I think it's a good.
Alright, I'm seeing some good things, but I just want to make it very clear. When we are using gas laws, what absolutely does the N have to refer to? Moles of a gas. Not just anything. I'm probably going to give you grams of gas, okay? Convert it to grams of gas. You have to implement a gas. It cannot be sulfuric acid. It's not a gas. You cannot put moles of sulfuric acid in its N. You got me? I've seen a couple people do it right, but not everybody's getting the mole ratio. Actually, I think it's number 2. Will you get and see if anybody else needs help on your side?
So for the mole ratio, it's asking for both of them people in the left. So would it be?
It's asking, that's fine. Mole ratios don't discriminate. They can compare any.
Oh, all right.
Yeah, reactants, reactant is fine.
I thought it had to be on the right. That's why I got really confused for a minute. I was like, what is this?
Yes, Ray?
Sorry, I have a bad habit of doing that.
Oh, okay.
A lot of our, in AP Chem, a lot of our pressures are, temperatures are 25 degrees Celsius.
I was just like,
Yeah, I'm just writing down my feelings first.
And then one more.
once you're done, please go ahead and go to number 12.
3,059 volts. Sweet, I think, right? Control it that way, right?
Hey, Ryan, go ahead and
We have some
we're
more.
going to do number 12.
Oh, no. Yeah,
All right, Miss Estudiantes, look up here real fast. 5, 4, 3, 2, 1. Thank you. Your given should be listed. Does everybody have their given written down someplace? Okay, you realize that this kilogram is about sulfuric acid, not water, sulfuric acid. And so you probably were like, oh, I can do K equals RT, but you did not have two variables. Well, one of them was the question, which you shouldn't have. The other one is n. So you have to find n first, and you guys can calculate there. And for n, you can find n using mole ratio. Alvin, what'd you get for your n value? 3,058. Something-ish like this. Give me a thumbs up if you get your moles. Okay. You're doing 150 times 1,000 divided by 98 times 2. Is this ammonia? Is by converting your kilograms to grams multiplied by 1,000. How many liters is this? It's a large number. 942. So I'll go 3. All right, guys, my work is here. Please check yourself. Move on to 12.
She studied your life. Yes. Yep. All right, so I got it balanced. Yeah. So here's the
Yeah. Start your year review right now.
So hold up, now I gotta do color and mold, when it's a mole ratio. Yes, 2 of them. Yeah.
We didn't cross out anything. That's an tree.
Yeah. Now we're good. We're sorting for volume again.
And I.
We have everything here. We had pressure, we had R, which is always in our head, 2.0, 821, and temperature. So the question was for volume, so that's when you had to realize that N's not really the question. N is what you find first, plug it in here. So that process of finding N required us to take grams of sulfuric acid, eventually to moles of ammonia, but that whole process. Grams to kilograms to grams, that's your conversion. Grams to moles using molar mass of sulfuric acid, and then moles of sulfuric acid to ammonia using its molar ratio. Where does this come from? The reaction BC, there's 2 ammonias for every one of those according to the BC ammonia. So that's from the coefficients. And then you got your N value, which you can plug in right down here. Also, I this process up here, that's about
Going in 90 days. Second. The angle is 14.3.
The metric one's molar mass and
Making 10,000 grams.
yeah, I think we have the molar mass energy table. Sometimes that mixes up, but when I put on myself, I can imagine this on top. That one is
It's already in.
You're trying to find it in the volume.
All right, 12. I'm feeling that I need to probably go over this one as well. Go ahead and tell me the reaction. Give me the one of the reactants.
H2.
H2 plus yields to ammonia, and you balanced it by, okay? So 3 for the H2, 1 for the N2 and H2. 10 kilograms of nitrogen, N2, is combining with excess hydrogen. That's like a hallelujah statement right there, okay? What does that mean? We're not dealing with. So we're not dealing with hydrogen, but if this did not say excess, maybe this had like 1 kilogram here, what kind of problem would this be? A limiting reagent problem. It would be an LR problem where you have to figure out who is the limiting reagent and limiting the amount of product made. But since it says excess, we're like, don't care about hydrogen, stick with this and go to what you need to later on. 550, what is that in Kelvin? 823 Kelvin, so that's our temperature. And then our pressure is, again, 250 atmospheres. So from our information here, we have temperature, we have pressure. What are we looking for? What's our volume? So the question is what volume is created, okay? So that's our question. What else do we not have just very evident here? Our N. So we don't really have N of what? Talk to yourself here. What is all this other stuff referring to? Yes, so it's talking about the gas produced, ammonia. So N is referring to moles of NH3. We don't have grams of NH3, we have grams of nitrogen. So what do you have to do to this? Eventually use a mole ratio to get to ammonia, right? So you can't do that straight off the bat. 10 kilograms of nitrogen must be converted to what? Grams, same setup as last time, right? What goes on top? 1,000 grams of nitrogen is equal to 1 kilogram of nitrogen. That's our metric unit from unit 1. Next step. So you're going 2 moles, right? So what goes on bottom? Which is good. 28 grams of nitrogen because it's diatomic is equivalent to 1 mole of nitrogen. So we went from, we had to put our grams on bottom, so they have to cancel. Now we're in moles of nitrogen. Who cares about nitrogen? We want ammonia. So what's the mole ratio? 2 to 1. 2 to 1. So 2 for the ammonia goes on top. 2 moles of ammonia on top over 1 mole of nitrogen on bottom. And so your units should cancel. You should guide yourself through kilograms, through grams, from moles of nitrogen to moles of ammonia. How many moles is that, guys? Say again? 0.3. So this is our moles of ammonia, and that's going to be your N value, and that's what you'll plug into ideal gas law, right? So I'm hearing that you've already rearranged this somehow. PV equals nRT. How do you isolate V? Divide by P on both sides. So that cancels. So V is equal to nRT over P. Everything is in its correct unit now. So when you plug in your P, your R value, your N value, your T value, you get what volume? Something like this? Okay. That's going to be your V, yes, in liters, because your R value allows for cancellation of everything but liters. Okay. Let's do this. The Kahoot. I need to review some content, like background content, make sure we're good there. Now, your unit review is due by the end of class tomorrow. I want to see it done for everybody. That means start a little tonight, get through some of it, ask me questions tomorrow in class, ask each other. But PS 14, I'll post the key tonight, so those of you who need to have more questions can ask. Yeah, right. Oh, you can use that thing. That thing. So, we have 15 minutes left. Let's do this. That game pin. So this is reviewing mainly information that would be on the multiple choice. Multiple choice is a lot of background content, definitions, gas law relationships, stuff about phase changes, and the free response is always just like the problem set. So the free response is going to be more calculation based. If you want to take a picture of this for more practice for yourself, go for it, but don't take this home because I need this for my response. Some of you need it. All right, I'm going to write the game on the board and get this party started.
Holidays.
Oh my God.
All right, the game pin's on the board. Oh, sorry. Water troubles up here on steam window pretty fine. And these are really, really quick this time, okay? Good, condensing water. Nice, okay. What law is represented by the picture below? PV and PV, P and V and V should be Boyle's law. Not bad. Which of these can be easily compressed? Okay. Easily compressed. Liquid should be maybe compressed, but there's not much space between their molecules. What would happen to the pressure of gas in a steel tank if it was heated? Okay. Guys, listen real fast. Temperature does what to molecules? Speeds them up. Are they going to hit the sides of the container more frequently or less frequently? More. More collisions is more pressure. More collisions, more pressure. Which of these takes the shape of the container it is in? Okay, no, liquids only. If anything, it would be gases only, but no, it's going to be gases and liquids. So whoever's blue people are, no.
No.
Temperature and pressure are blank related. Guys, let's review. What is temperature, increasing temperature do to particles? Speeds them up. So increasing temperature speeds them up. What do they do to the container? They collide more frequently. So if it's an up and up, it's a direct relationship. Okay. If it's like this, it's inverse. Gas will always occupy the total volume of the container, true or false? Yay!
How is that not something?
When does it not?
Because if it's in a balloon, the balloon doesn't fully expand.
It's filling its volume of its container, though. It's filling the balloon. It's not like, I'm gonna stay on this half of the balloon. It fills the entire, whatever the shape of the volume of the container it is, it will take it.
Oh, gotcha. I was really confusing that one.
What would happen to the volume of gas in a balloon if it was heated? It's a great application.
Upside down.
Good, good. I don't need to go with that one. That's the hot air balloon one. STP.
Cookies. 26.
Okay. Overall, we know what STP is. Keep going. Which state of water do the particles move about most freely?
Wow, I don't. I just guessed. God dang it. I think it's liquid.
What? Who brought liquid water? No, guys. Gases, they bounce a lot. Liquid, no. I'm disappointed in you. What is there between the particles of a gas? Nothing. There's nothing between the particles of the gas. Maybe other gases, but that's still between them. Nothing is empty. Literally nothing. No air, nothing. Absolutely nothing. Gay-Lussac law describes the relationship between
I picked something. We get it. I remember.
You need to review your foldable.
I remember. I
P.
remember PV over T.
Yes, but it's P and T. And the pressure of a gas goes up by 5 times. 5 times. What will the volume be? Okay, some of us got there. So if the pressure is quintupled, okay, it's going to go up by 5 times. The volume is inversely related, so it must go down 5 times. So that's why it's 1/5 of the volume, not 5 times the volume, because they're inversely related. So when you multiply by 5 times, the other one's going to have it be divided by 5 times. Inversely related. Okay, based on Boyle's law, the volume is increased from 20 to 60 liters at 60 atmospheres. It's easy math. You got this. You got this.
Oh, no. I think it's so long.
Okay. Let's talk about this. Let's talk. If you're tripling the volume, right? Tripling from 20 to 60, what's going to happen to the pressure? You know it's going to go down, and it's going to go down by 3 times amount, right? So you're going from 60 atmospheres down. So I try to keep the numbers the same. See, this is P1, V1, and this would be V2, and P2 would be 20. The numbers are basically the same. They're reversed. Does that make sense? You could do mental math on your test like that. You could. Oh yeah, not in seconds. 10 seconds. What would happen to the pressure of a gas in a syringe if you compressed it? Okay, you guys did that with the marshmallows. You saw the pressure increase inside the syringe. Good. The ideal gas constant, R, is... No, it's not. liters per mole, okay, 0.0821.
We on the
Okay.
leaderboard.
That's
Did
not
you see me?
horrible. What are the conditions at SCP?
0, 5.
No. It's
What? 0 Kelvin is when all matter stops moving. 273 is 0 degrees Celsius. 0 degrees Celsius is 273. PV equals RT is the combined gas law. Not the best answer. So it's the what law? It's the ideal gas law, not the combined gas law. What's the combined gas law? PV over T is equal to PV over T, right? The one to choose. When using the ideal gas law, volume must be in. Okay. No. Liters. To convert degrees Kelvin to Celsius. Okay. What happened?
They switched Kelvin to Celsius.
They switched it. So, like if you're going from Kelvin to Celsius, you must subtract 273. If you're going from Celsius to Kelvin, you must add 273. Alright, one more.
You see me on the leaderboard?
Nice.
Oh, yeah.
Oh, there we go. We're done.
I was the
Okay.
highest climber.
You were. Okay. Thank you, people. I need this information. Okay, last thing before we go. Warm up that I didn't do with you. Talk to me right now. Orally answer these. Oops. With me. Okay. Think about, I want you guys to write on your paper, solid to liquid to gas. AJ impact. Solid to liquid to gas. It can be anywhere, yeah, someplace on your paper. So like this, solid to liquid to gas. And I want you to write which, is that direction an endothermic process or is that direction an exothermic process? Write it down. Write it down. So is that the endothermic direction or the exothermic direction? Everybody. Why endothermic?
You're adding heat.
Right, not necessarily heat. This is a low kinetic energy system, and this is a high kinetic energy system. So how do you get from low energy to high energy? You must add energy, and adding energy is considered endothermic. So if you go in the reverse manner, you go from gas to liquid solid, exothermic. Okay, so that's what I want to do there. What does a phase diagram look like? It's the Y with the triple point. Okay, so on a phase diagram, what's this first one? Solid, liquid, gas. What's the heat curve look like?
Students in class, there will not be a kickball tournament tonight. It has been postponed until a later day. Thank you.
What does normal boiling point mean?
Oh, that's 100.
That's for water. What's normal mean? 1 atmosphere is what normal means. You draw a dash across your graph and you tell me what the normal boiling is by looking at the interface between liquid and gas. And normal melting point would be at 1 atmosphere and then dropping. So this could be like negative 200 for a substance and then 400 degrees or something like that for a substance. You guys need to jump on Mythbusters. Your project data should be to me by next week. Information regarding your data collection.
You heard? You gotta do that.
You gotta do that.
Will be told in the comments, to the comments area.
You need to schedule a time with me.
Thank you.
Schedule a time. You guys might